Good morning. So today we have an eminent person, Mr. Nagaraju. He's currently associated with Intel, and since 2017 he's been associated with Intel, and he has worked towards a 4G, 5G, 5G technologies, and also with multi-SIM feature for both Mac and iWatch. And currently he is a silicon debug architect engineer in Intel. He also is working on pre and post silicon debug enabling. He has contributed towards 15 plus client products and received 6 plus quarterly best performance business group awards, CEO attention award, and many other recognitions from directors, management, and PEs. He's passionate towards a pre-post silicon bug findings, boot and debug flow across SoC, IoT, and computing. And apart from his professional work, he works on IoT projects as hobby, and he has great love towards Bible teaching to group of children and hobbies like playing instruments, screenplay writings in his free time. So we are happy to have you here, Nagaraju, and the dice is yours.
Thank you very much. Hey everyone, thanks for your time. Hope you are safe and doing well. So today I want to go through some of the industry's movements that's happening. Now we are in 21st era, and we are moving to the industry is revolving. The revolution is is moving in the next phase, right? As we already know that we are moving to industry 4.0, 5.0, 6.0, and many things so on, right? So we'll just talk about what the industries are focused, the currently the proof of concept, that they're focused and they're moving, that okay, this is what we have planned in 1990s, but now we are moving to 2040, 2060s. So where we wanted to be land on. So that was the challenge that industry have in front. And we'll see what we have, security threat when we move to industry 4.0. So let me share the topics that we are going to discuss. So this is the topics. First we'll talk about the building a foundation. What is the foundation that took place for the 4.0 to brought up? Then we have cloud rewards versus what is a cloud that is giving a benefit to us, but at the same time it is giving a cyber security risk as well, right? So we'll talk about that. We'll discuss about that. Then we have a human challenge. Then we have a data challenge when we are moving to industry 4.0. Then we have some security challenges for IoT, and we'll also see how do we tackle that security challenge, how do we do that, and finally we'll give a glimpse on that. So let me start. If you have any questions, feel free to stop me at any point of time. I'll try to address, but yeah, let's start. So industry 4.0 building foundation. So you already know the first century, the first industrial revolution started with mechanism. So water stream power and all. Then we moved to mass production, like assembling the electricity, the cars, and all, right? Then we in industry third revolution started, where where industries are focused, how do we automate the computer and the automation process for the mechanics. So this was the third revolution. But now we move to the fourth revolution, where we are more focused on cyber physical systems, which the mission to mission will talk each other, M2M. You might be aware the M2M protocols and all, right? So we are moving to that phase with the IoT included. But when IoT included, we have a lot of security related, cyber related threats and all. So how do we manage, right? Industry 4.0, you can call it as a bringing together IoT and AI together is calling as a industry 4.0. Okay, if you see, there are different technologies like local database, cloud, IT, everything. And at the end, you can also see that any product that you buy on the shopping, wherever you see the barcodes, sensors, and there are sensors in cameras in the the industries that you see. Then you see a robotics, which they are manufacturing a devices, and you can see a smart IO in our home also, right? When we recently, I think we are all using LX devices. There are many other devices, the smart devices that we are using, and then the camera, smart cameras that we are using. So all these are connected to, one of the other database. Either it can be a local database, or it can be a cloud database, or it can be Azure, a Microsoft cloud. Um, but the interesting challenge is how are we going to manage all together at once. So now if you see barcodes, sensors, robotics, and smart IO cameras, so all these having their own cloud individually. But when we move to 4.0, now all of them are connected to one, database. So which is nothing but the cloud. And we have an artificial intelligence involved, where we need to train the system to understand what is the pattern that the user is trying to use. And in the future, we wanted to, the system should take care. The no human intervention is required, right? So that's where the challenge is in front. And now how are you going to handle all together in once? So that's where there is some device wise node is introduced, which is a master, the master system, which anything that we are connecting will be logged into this mission. And from this mission, we are going to talk to the individual local database on cloud and all. But this is very crucial, and we need to see it as a security concern here, because we are accessing our information through the another third party device, right? So but this has some of the features you can see here. It can integrate IT, all the IT features it can integrate. And protocol transformation, you have some protocol that been sent, and on the other side it can translate and send it in a secure manner, for adding some of the bits, additional bits and all. Then it can also do an edge logic and mathematical algorithm in order to secure our information. So all that that the payments that we are doing nowadays, everything is will be very secured with this node basically. So this if you see some of the information, industrial companies have potential gain from 5 to 40% in cost reduction when they adopted this IoT. Do you have a question?
No, we can proceed.
Sure. When we adopted this, the industry 4.0, it was started in 2011. Now slowly we are seeing all the industries have started accommodating this, the cloud based IoT. For example, you might be visiting any industry, right? You will see everything is automated, everything is under the cloud. There is no local database missions that we are storing now for operating any of these IoT sensors and all. But everything is moving to cloud. When they moved this kind of technology based driven IoT 4.0, then they see a lot of cost reduction from 5 to 40% is a very good amount of for companies save. And you can also see that there are the different protocols and data restriction challenges. Now when we move, obviously when we have moving to the new technology with the vast profit, there will be a huge amount of risk also, right? So the risk is here, is the restrictions on the challenge, that data transformation. We are moving to the digital transformation, and it combines the IT and OT level interoperability, right? And it must use the larger size or medium size projects. So this was the biggest, the challenge that they had. But again, it was a great benefit for industries to in terms of cost reduction. Now let me show you something, the timelines where we are and where we go in future. Right, the third revolution started. If you see 1940 to 2000, we call it as a third revolution. So and from 2000 to 2040, we are moving to the industrial fourth revolution. Oh, what is after 2040 is a industrial fifth revolution, right? IoT industrial 5.0. So let me give you some glimpse on that as well. Okay, there's a funny picture. how will digital transformation affect as a human. So you can see we started with missions, then we are in the phase of robotics, and in future 14.0 the robotics will come and they'll kick off human. Just funny. Okay. Okay, this is workforce, and now let's focus on the IoT 4.0. And what we are discussing is IoT 4.0 and the challenges, right? Let's see what is happening here. So as we know that it was kicked in 2011, that device to device communication started. So you can do porting. You can do screen tethering, right? Everything you can do it. So this is all happening with the Wi-Fi and other networks that we have is a cloud technology. But at the same time, you zoom in and you see a cyber physical systems. Nowadays, this has been increased a lot. The research says that almost 70% are people who are in rural areas are impacted by this cyber physical systems attack. We get links, we get calls for unwanted calls for for cyber attack and all. So we all our devices are now already moved to IoT. Yes, we are in IoT industry 4.0, but now we have to see, as engineers, we have to look at how do we tackle this IoT 4.0 risk that we have in front, right? So that was the main intention of this session. So let me share the cyber physical systems. What is the attack that is been happening in nowadays, and how are we going to tackle this? So I'll also put some challenges in front of you. So just think on, how do we tackle this industry 4.0 revolution attacks, and say, and save this ecosystem from the attacks, and move to the IoT 5.0 also. So then, if you see, we are adapting the human knowledge to emissions. So we are sharing our knowledge to emissions. So basically what we are doing is we are training a system. How do we address an issue? How do we address a process? How do we address a challenge, right? So that's what we are training a system. And once we train the system is having an intelligence where it learn the pattern that we are going to give. And when based on the instructions and based on the patterns that it been recognized in the future, it behaves like a human, right? That was very good in front in front of us to reduce the cost and the human efforts and all. But at the same time, it is a huge impact on the um, human and the world, right? Because every mission will understand what is the security concerns, what is the vulnerability inside. And obviously we'll have some giving some leverage for the, other hackers to hack the system and rule the cyber world, right? The purpose of this to control the physical process and adapt itself real time in the new conditions. That's what we are doing, right? At the same time, it was an autonomous process and it is a cooperative element. So it will cooperate with any function. So it will not, okay, for example, I design a system and I teach, I have given some pattern. Now the system does not care about who is the author of that mission, right? Whoever comes with the same code of authorized access, it will cooperate with that element. So that was the main challenge that we have. So if n minus one person, let's say the next person is coming who is not at all authorized person for accessing the protocol system, then it's a but he has the authorized code that to access the system. um, the system will still allow to create an autonomous and cooperative elements. So this was security concern, right? So if you see, the industry 4.0 is revolving all around the autonomous systems, simultaneous models, okay, which is a digital twins, which is coming in new models, right? For accessing for digital new transformation. And we also see the connectivity of IoT, security, big data, AI, and manufacturing, okay, augmented reality and VI. So So these are all the main revolution that is happening around the industry 4.0. But now where we are focusing the security cyber physical system is the cloud computing, big data, security, and connectivity of IoT. These are the four, the critical factors that we need to pillars that we need to consider in IoT 4.0 in order to reduce the cyber threats that we are going to have. Okay. Now, if you see Industry 4.0, it started with the production design. So there are three phases that you can consider Industry 4.0. One is production change. The other one is the manufacturing and supply chain, and the last one is the asset chain. Okay, what are this ELM, SCM, ALM is nothing but when we, for example, we want when a new product was introduced in the market, how it is coming to the user end. It started with the production design. So any company will go and start, okay, I need this product. The product designer will design the product. Then there are some engineers who involved and try to build that product. So then there is a validation to team who validate and test the product. Okay, once they validate, then they will give to the manufacturing. Now it comes to the manufacturing, and manufacturing has some protocol, like the reference, the product design. Based on this difference design, and they will try to see the demand of planning, how many customers or how many users are interested to they will do some sort of survey. Okay, Google any survey they will do, and they will try to find what is the demand planning. Okay, how many users are interested to take this product. And once they see the demand is huge or less or some medium, then they will try to do a production planning. Okay, they will try to productize the planning. In the sense, they will try to implement it in a manufacturing. They will see how reality that we can make this product design to a product planning in a real manner. Okay, all that we are seeing in a physical the phones, the IoT devices that we have in our hand. One of the phase they went through is the production planning. In the sense, yeah. You have a question? Go ahead. Yeah. Okay, so once it has entered into the production planning, then the material will be productized, and they will start supplying it. So to the manufacturing again. So once the manufacturing is done, again the validation will happen, the test and validation, and finally it was delivered to the customers. Okay, so in the customers, delivering the customers, so we need to see what is the operation, maintenance, and what is the disposal and recycling of the device or the product that we are sending. And obviously we have to do in a customer support all the time throughout the product life cycle and all. Right, so this was the life cycle that's happening in any of the missions that we are having, products that we are having. But especially in case of 4.0, right, we need to mainly concerned about two things. One is the cyber security, sustainability, and value. The future revolving is the industry 5.0 is all going like this was just an emphasis how after the 4.0 the industry 5.0 looks like. So if you see the vertical integration indicates that the top floor from the to the the bottom floor, the horizontal of integration indicates across all the product life cycle. We need to make sure that it has organized standard with the law, the business segment, big data, everything is under control with the cyber security and sustainability. Okay, so any questions? We move to the cloud. Okay, so let's see what is the cloud rewards that we are getting, and what is the cyber security risk that we have in the cloud. We have seen the cyber security, CPS, the physical systems that's been autonomous and cooperative to non-authorized and authorized, elements in this product phase. But now let's see in the cloud computing, what are the security concerns that what we are worried about. And so this is what the IoT structure is. Okay, you already know this IoT structure, but I'm just giving glimpse on this. So IoT structure is a combination of sensors, computers, edges, internet, and and cloud, right? Obviously there will be a data communication throughout this elements is nothing but is called as a Internet of Things. Now when we when we have a sensors like any RO motor, any the smoking sensor, anything, we connected to one of the device, which might be an Arduino or any other device. Then we'll use a software. We'll program it and in a way that it behaves. But in industries, they used another edge device, which is a Wi-Fi router or the network, which can be connected through to the cloud through an internet service or intranet service. So they will try to operate the systems from the cloud now, right? Now in this two phases, the sensors and the computer devices, we are doing our projects without the cloud basis also we are doing, and we are training the system, we are operating the system, and we feel the IoT is very nice. But now when you really see the industries are moving to a cloud based, it was the traffic, the data traffic, the network, everything is a huge. Now you see what is in the cloud. The cloud is nothing but it's not on the air, it's basically you see the missions. So these are all the cloud databases that's been located in one of the location, where everything is connected to one mission is connected to another mission, and these are the data servers. So everything is for example, the Facebook, WhatsApp that we are trying to use, everything is going and using the cloud. So these are the cloud and virtual, it will create, for example, each cloud database can be a replica of many virtual databases. Okay, so this is how it will be. Now, if you see the cloud-based side, what exactly the inside the cloud is happening is, you see a remote industrial assets. These are all the remote industrial assets. You can think of anything, any devices that we are seeing, remotely that can be controllable, right? Remotely we can operate the system. So everything is one or other way they have to come, and they have to give, and they have to connect to an cloud technology. Can be an AWS, right? Amazon Web Services. Now we need to configure the device in Amazon Web Service in order to access the cloud, that we know. But when we have all the devices that we connected in Azure Web Services, now we have in 4.0 that we say that all the devices or everything is going to one channel or one connectivity mode. Then it is a vulnerability or security threat for the hackers, right? So that's where we are going to introduce the node, device wise node, and actually it's a company, they introduce the node. So in this node they will have the surveillance system, which keeps monitoring. This is not the physical, this is virtual, and this keeps monitoring the data that is being coming in, and a it adds a protocol to the data that is going to feed into the web. Okay, now if you see the remote industrial assets, the data directly coming in to one of the gateway, any gateway that we are trying to send payments or receive payments or accessing some system, there will be some gateway, right? So we are entering into the gateway, and from gateway we are going to the Amazon Web Services. This is the one way of protocol, and obviously there is an encrypted system that the data is being sent in an encrypted manner. But obviously when we have a multiple systems are connecting and sending a data in a connectivity manner, there is a vulnerability chance. Now having this device, what they are going to do is they are going to introduce a new protocol on top of encrypted data. They add another layer so that they keep on monitoring the surveilling the data every time. Any vulnerability, any security threat that's been attacking uh, to this Amazon Web Service, that particular asset will be tracked and try to revert back. So this was the benefit of having this node. So if you see IBM 1989, So they have implemented, they started doing this, understanding this. Now if you see, there are other technologies like Telite and DeviceWise. So all these platforms, right, they are these are all the companies that they are focusing on IoT cloud businesses and all. But now DeviceWise is one which came in, and they took the lead of the IoT platform by managing this cloud vulnerabilities. Okay. So yes. So if you see the rewards that we are having from the company rewards, if you see 40% of the cyber security or physical operations, and they're very less 8% that we have a cyber security chances, that we can see that okay, low amount of risk is there. But obviously if you see the rewards side, 40% is good, and similarly on the physical, this is on the cyber security. But if you talk about the product design, what is that, the cloud that is giving a reward, right? So if you see, the cloud is going to give a reward of 36%, 36%. Okay. And now asset life cycle is also more, but the more chances of having is on the manufacturing operations, right? From the top to down, AI assisted process and all is actually a less. So this was the reward is less. But yeah, obviously the product design, asset life cycle management, quality assurance, they are all fully based on AI assistants, or where you can see a slightly high chances of having good rewards, right? This was an initiative that took by the industries. So industries are focused mainly on the five topics that you are seeing, right? One is the product design, what is the life cycle management, and quality assurance, and manufacturing operations, and cyber security. In all of them, they can see a good amount of cyber rewards are happening. But at the same time, if you see which are the best cloud technologies that they are going to use, is hybrid cloud deployment. And you can see most of them is 32% is basically a hybrid cloud deployment, because some of the data they are putting on the computing machine, and some of them they are having it in the cloud. And the private cloud data is slightly less, and it is 23%. Right, this is the strategy that they are following. And now with the very less percent is breaking a cloud provider is agnostic. So if you see a 2% people, the cloud providers are very agnostic, but most of them are they're going to deliver the hybrid cloud, just in case if in the hybrid, right, you will have your local machines as well as local database as well as a cloud. So whatever you are storing in the local database, it will be cached or replicated on the cloud based services also. So this was the most optimization cloud strategy that manufacturing is following. Okay. Now if you see one of the example that IBM trying to approach is how are we going to tackle this attacks, right? So this was the architecture, solution architecture they provided. As you can see, there are some event collectors, ABB, event forwarder, and event collector. So there are two, the red color highlight ones are the something that we need to the IBM is focused. Whenever we send any devices, you can see three layers: L11, DMZ, corporate. So corporate devices, everything are in a secured manner, right? Now when we talk a system to system, so event collector will try to forward that request to another collector, and that will try to analyze, the system will try to analyze the you know the so now it is going into three level of cyber IoT security level interfaces, and it try to validate in each phase. Because of this, multiple event validator and forwarding request to for for protecting the cyber attacks, right? So this was basically enabling the effective monitoring for the control systems, and enabling a fast based fact based action for any abnormal condition also. So this was the challenge and they had, and I think IBM had some solution that they are providing. Yes. So moving to the human challenge and data challenge that we have in front. Okay, so let me give you some challenge that we have in front. And as an engineers, we need to see how do we, improve this, take this as a challenge and come up with some innovators. So what is your biggest challenge in implementing in this was one of the questions that was asked for one of the senior industry folk, and then he said 53% are voted like this. So interoperability, new solutions, legacy applications, right? Interoperability, right? This was, and the second one is insufficient senior executive support. Now we have hundreds of issues, and obviously the support is limited, and also the insufficient of employee skill and knowledge. So IoT with the cloud AI, so this is a emerging technology, right? So on this, the employees, the skill set is very limited, so they are very efficient, and 40% of the the challenge that we have in front. And and also the data, the ability to collect, ensure, and properly analyze. So though we have we have a, proper AI methods that to ensure the quality and proper analysis, but still we do lack in the data ability when we want to implement 4.0, because it's not the 4 5 devices that are being connected. Millions of devices are going to connect to a cloud in one channel. So collecting the data, ensuring the quality, proper analysis is also one of the challenge that they had. And the next challenge that they had is clarity of the target state and architecture. So these also insufficient state. So the architecture that's been implemented is based on some certain level of features, but as when we have security threats are attacked, and more user demand are increasing, the target state is it needs to be changed from day to day, time to time. So there is no a concrete clarity for defining an architecture for this industry 4.0 initiatives. If you want to take this as an initiative and apply to the to a system, then we do not have a baseline of architecture which says, oh, this is the structure, this is the architecture you need to follow and try to implement. No. So day to day, time to time, the things are changing. So this was an insufficient clarity. Then we have cyber threats. Yeah, obviously 26% of challenge that we have is one or other way the cyber threats are happening. Then 23% no return of investment, and 21% is organizational cultural was to change, because anything new that organization will try to will be an ambiguity to adopt it or not. But yes, this was one of the organizational culture needs to be changed. They have to initiate and adopt to this new industry 4.0. Then the other one is cooperation between IT and the OT teams, the physical teams who are working on the ground and also on the cloud software service. So cooperation. Okay, these are all the technical and non-technical challenges that we have, and this is a human challenge. So as a human we have this challenge. Okay, but if you see the data challenge, what level of challenges we have in the data. Data is something that plays in the the computing, right? In the computing, how the quality the data being sent is critically matters. So for example, you are sending a 50-bit 64-bit data, and you are expecting a 128-bit data as the output, right? That was okay. Another 64-bit where it was added, right? That was the biggest question. Now someone might be added in between the flow, or another operator like XOR or OR gate that we are implemented in the design that's been get added to this 64 to 64 and getting 128. This was one of the questions in the computing, right? So similarly, if you talk about the data challenge in IoT is something negatively impacted. So successful manufacturing quality. So 40%, if you see the 40%, they strongly agree that this was negatively impact on the successful. That means it was a positive data is good, but 49% they agree that okay, this was slightly the quality is less, right? The quality is not successful is what they're saying as an engineer level. But when it comes to company side, okay, the how difficultly They are collecting the data, blending the data from all the sources for analytics, right? Data analytics. So 51% people they are agreeing, only 21% they are they're strongly agreeing that they can source the data from data from all the sources for analytics. And 51% are slightly agree. They say that okay, it's hard for collecting the data from all the sources. So this was a data challenge. So when we have huge amount of data, obviously there will be a negative impact. Also there will be difficult to collect the data from all the sources. Okay, these are the two challenges that we have, data challenge and human challenge. Any questions? If no questions, we will see on the security challenges. Okay, for and how are we going to tackle in a real time. So the security devices, if you talk about the cellular, right, 4G, 5G, and 6G is also emerged recently. Now security cellular IoT devices, the life cycle, right? There are flaws in needs update. So every IoT device needs get to update every day or every time to time across the product life cycle. Only then we can say that the product is good. Otherwise, if you are not updating, then the flaws is still there. Security flaws are there. So it is a security challenge. Another one is building effective detection and response. So right now all the systems that present on the cloud or IoT Internet of Things are less effective for detection. Okay, the response is also very less. So we need to monitor for the attacks. That was one of the assumption. With this assumption, we are trying to tackle that. The other one is discovering and terminating the shadow IoT. So anyone can answer about shadow IoT if you are aware. Anyone? Any thoughts? What could be the shadow IoT?
Might be they're unaware of it. Anyone can answer?
Okay, so shadow IoT is actually um, whatever the data that we are doing is actually trying to uh, um, uh, act as the temporary channels for the cloud. For example, I'll give an example. What could be the shadow IoT? When I am trying to research, I found this. For example, when you are doing some transaction, right? You are sure that the transaction B is going in one channel. No, the transaction is going in a shadow manner. So the real transaction is actually happening, but there is something background that the transaction is still following in another pipeline, which is a shadow. And this is very secured in terms of the gateways, in terms of cloud, everything. But everything is why this shadow is introduced. The shadow is introduced in case if the cyber trying to attack. So how exactly the anti-cyber attacks also, right? So attacking the anti-cybers, attacking the cyber attacks to with the cyber technology only, right? So that was the introduction. Now in the real time, if any cyber attack happened, so the engineers who are trying to find where this attack happened, so they enter into this shadow IoT, shadow, the protocol that's been sent. So and then they understand, okay, okay, in this transaction flow, this particular event was triggered by attacker, and okay, this event where it's coming, where it linked, so they will try to revert back the attack. So this is how our government officials are working on cyber attacks in order to resolve the issues. Okay, now you got the some glimpse on this, right? So this was very interesting and also advantageous in terms of attacking the cyber attack. So the challenge is discovering and terminating it again, because now these devices are operating invisibility. This shadow IoT is not visible, right? It's not visible to at a data level, mission level, and all. But yes, it still exists, and it is still a layer that's been underneath the original protocol that's been happening over the IoT communication. But yes, so this is this we need to see how efficiently we can make these devices operate invisibly. But still, I think the shadow IoT is now cyber attackers are also trying to understand how do we attack this shadow IoT. So this cannot be attacked, but now they are trying to attack the shadow IoT because there is some visibility. So this was one of the challenge. So how do we make sure any device that operating is can be operated as invisibly? It can be invisible to the system, the human, and also to the cloud, right? And but it is operating in a shadow manner. So this is one of the areas that we can try to take as a challenge, and how effectively we can make our systems to operate it in a invisibility. Okay, this way the more invisibility, the less cyber attack. The more visibility, the higher chances of cyber attack. That was the formula. The next one is the eliminating the threats for the data leaks. And you see, the data leaks is one of the biggest threat, security threat. So any company having some secrets are being data leaked, so this was come under the data leak threat, right? So how do we eliminate is one of the security threat that we have in front. So sending to an unauthorized endpoints, okay, authorized to authorized only we have to send. But yes, there are some unauthorized endpoints we are sending the traffic, then yes, definitely that is called as a data leak, right? So how do we eliminate that kind of unauthorized endpoint traffic? The next one is preventing the network or device takeover. Um, this ransomware is one of the the biggest malware that was coming in systems and trying to rule the entire device, right? So once a ransomware enter into the mission, you don't have control. So the ransomware software will malware will take over the system and try to introduce more number of virus in order to hack your systems. So this was one of the new threat that was also coming in to the IoT. Recent For now we have seen ransomware in our laptops, in our mobiles, but now this ransomware was entering into as a new threat to the IoT. So any device that you're trying to operate, like fan, remotely or operating fan, AC, any system in the cold, are now entering into ransomware. So um, so that if ransomware enters, then you no need to operate, it will take over. So we have to prevent this kind of network takeover, takeover tech, malware functions. So these are the five basic challenges that we have, and this is very important to understand. These challenges are coming into IoT. So far we know the security challenges are there in everywhere, in every phase of the life. But yes, if it is coming to IoT, and IoT is our future, then yes, it's a very big impact on the humans, and also on the net, for everything that is that we are playing, right? So if it go over the control of this third party mission to mission, then it is out of control. So we have to tackle this as a challenge. Okay. So if you see, there are some devices that the IoT devices that are target for attacks. So which devices, right? For example, any devices, they are lightweight and constrained IoT devices, right? They can be target for attack. Which devices can be target for attack? They can be lightweighted. It means the lightweight in the sense is not about the physical weight. It's about the technology that's been implemented, or the design that is being implemented. If it is not with the more security cryptography and algorithms that was being added, it was not. If it was not added as a cryptography algorithm, then they are constrained to be attack. So then uncontrollable deployment environments. It means when you deploy an IoT, we make sure it should be an uncontrolled environment. So for example, Amazon Web Service is a trusted environment, right? Now when we this was a controllable, but if there is any X environment is coming and giving a best, the platform for us to deploy our IoT products or projects, right? So if it is not in a controllable environment, then yes, it is leading to target for attack. Okay, then many locations are inaccessible by solution deployers. Okay, this was one of the challenge or the target for attack. The next one is a scale of deployment rising. So when you rapidly increase the deployments, for example, you are deploying 100 IoT products and you are deploying thousands, and now you are moving to 10,000s and lakhs, right? The more the scale is improving, the high chances of attack. If the lightweight constrained IoT devices are in place. Okay. Then IoT devices are, everyone think, okay, these devices should be a long lived, but obviously due to security flaws that not been updated on the device, and obvious the device cannot be long lived, and it can yield to target for attack, right? And yes, so our devices, all our devices that is connected to the world are not secure. So this was a final statement for the challenges, right? Any device that we are using in nowadays, anything, it's not at all secure, and we must plan for security breaches, right? So this was the context for the targeting the attack. If you see about design security solutions, I'm just going fast because I think this is not much needed, but let's see. So if you see, there are horizontal and vertical, right? And a little impact and maximum impact, and few impacted, all affected. So design security solutions, how in the design, right? How in the design, what is the area that we can see as security problems, where we will not see the security. Now, if you see, widespread of damage is happening in the national infrastructure like power grid, military command control, food, water supply, petroleum, etc., etc. Any national infrastructure are highly impacted because of this design, because design security is highly impacted. And the less and simpler sensor data. If you are collecting a sensor information for your project, you don't see a security threat because it's very simple data. But if there is something a national level infrastructure involved, where the power grid, military, food supply, water, petroleum and all, there is a widespread of damage, and obviously there is a maximum. And you can see, and most of them variables, personal monitoring, financial institutions, government, medical devices, vehicles, home automation, these are all partially they are impacted and partially they are not. Okay, so the more we need to consider how do we tackle the challenge around the national infrastructure. Okay, so if you see, one of the guy who actually hacked the system with medical devices by and he is trying to control a medical device remotely. So this was the vulnerability level matter, security privers in car. So there are many attackers, they are trying to attack these medical devices in a national infrastructure level, and trying to throw a challenge for engineers for cyber attacks. Okay, if you see the life cycle of an application, now we have seen what are the challenges and the security solutions where we need to focus more. So there are vast number of areas that IoT is playing, but where exactly we need to focus and trying to you know take a challenge as a cyber IoT challenges and security challenge, and try to avoid, right? So now if you see about the life cycle, right, it all happens in 4 cycles. Any application, it can be develop. The first one is the development. Then we have to scale up the devices. Then we have to operate. Operation is something that we need to keep continuously support the device with the customer, and obviously there is some point that the device may not function or the product is end of life cycle, right? So if you see the physical, there are five sensors, sorry, physical sensors, smart sensors, and there is some data, gateways, intelligent networks, and IoT now solution value, which is monetizing the application and all, right? So these are all the some of the how do we make the devices smart, right? So we can make all of these devices as smart and communicate to one to another, mission to mission, right? So you can see with the physical sensors, we can collect the data. With smart sensors, we can target and try to sense the data. Then we can in the short range of communication, we use intercoms, we use Bluetooth, Wi-Fi, and all for one of the gateways in order to access the short range data communication. If you want to access the long range, then we use some kind of gateways, right, and to transmit the data over the network. Then we also having the new technology that has been coming in, is edge computing, edge technology, edge networking, where the global networks are connected to one secured IoT network, right? This was an intelligent network which monitors all the networks in one place, one underneath layer. And we also have rest of IoT solution. So these are all the things that we can make things smarter and smarter in order to make our solutions, IoT solutions, success. And finally, we need to see how efficiently we are success in implementing the depth of the smart devices, right? Okay, so the final things I wanted to share is the IoT security attacks are increasing day to day. Okay, could be barrier to IoT adoption or the scale level. So anyways, so we are seeing the IoT securities attacks are increasing day to day. So things we need to take care in future is we have to prevent, detect, and response essential to minimize the impact. Obviously, the impact will not be zero, the impact will be with some percentage level, yes, but we have to make sure it should be a minimum impact. These challenges we have to deploy it in a secured IoT applications, right? The methods that existing to meet these challenges, to achieve a good outcomes, are not sufficient. We need to move to the more methods and more challenge, more solutions space in IoT in order to avoid this kind of risk and make industry 4.0 success. So industry 5.0, you might be seeing it, right? Horizontal and vertical integration, where we need to ensuring all they are communicating through a one intelligent network, is a edge computing network. So that's where we have to land it, but yes, these are the challenges, and thank you for your time. Have a good day. Any questions? If you have any questions, I'll try to answer.
Excuse me, sir.
Yeah, hi.
Sir, in case of data leaks, you mentioned unauthorized endpoints, right? So can you
Right.
please give any example and elaborate on how do we avoid these data leaks? Like example related to unauthorized endpoints.
You mean how do we address data leaks?
Yes, yes, sir, yes.
Okay, sure. So data leaks are something that is being triggered from one mission, right? So one mission to another mission. For example, in my laptop, I'm trying to access the data from another system with a protocol, right? How do we prevent this kind of breaches? This was the question. So for example, one of the example that I can give is password. So the more strong we keep the password, the less chances of data leak. But the more chances of less strong password is high chances of data breach, right? Now Apple, let's take about an Apple. How they are going to address this data leak? In other other than Apple, any other devices, if we have some password, and one or the other way we are saying that my Facebook account is hacked, my Twitter is hacked, my Gmail is hacked. So why this is happening, and how Apple is trying to address? If we can target one company, right, like Apple, then we'll try to see how they are going to address, and that gives some idea how we can address these data leaks. So Apple is mostly based on the single sign security breach. So it means what they do is generally whenever someone is trying to access data leak, data breach, they are trying to personal data. They are trying to leak it, right? There is something in the databases. So in Apple databases, there is something called personal data leak checker. So there are multiple checkers, data leak checkers. So at the very end of each data that's been passing over this network from the Apple, right? So they from the Apple side, the network side, they will keep checking the data leak checkers. So the data leak checker could be personal, professional, and it could be related to security data leak checkers and all. So they keep on checking the data every time, but they cannot read the data. They will just try to check whether this data that's been sent is a harshed emails or not, right? Harshed data or not. Now, having these data checkers is one of the good way of addressing the data leaks. So the more the checker, inside the checker, you will have some protocol where you will try to analyze what kind of data that's been sent from the user and to the destination. Is it the same pattern or not? Okay. If when for example, if you pad I'm sending 32-bit data, and to access the data, to access the password, okay, I'm sending 32-bit data. Password is having a 64-bit. Now 32-bit and 64-bit are get appended at the end, the destination side. It means at my side, right? I can see that 32-bit and 64-bit get added, right? Appended. Now the data is increased. Now during this process of data breach or accessing the data leak that I'm trying to do, what will happen is the Apple will, I'm taking Apple because I have been researched on that. So what it will do is it will try to keep checking the data leak checkers, right? It will keep check for the patterns. Okay, 64-bit being sent from the user, why it is sending an appended 32-bit. So what is this 32-bit? It will try to analyze. So this is an automated intelligence. Now I think we are moving to iOS 14. It was being more upgraded in order. It was more intelligence that it itself will try to understand what kind of pattern that 32-bit data will be sent, right? Appended to the 64-bit, and the 64-bit data that we sent as a data, it will be in a pipeline. What it will do is this is the data from user data, and this is the 32-bit data that is going to get appended, and it will try to restrict that 32-bit, and it will erase the data. So this was inside this checker. For each of the system, for each of the data checker, there is a different logic, but in one of the checker, the analysis and the logic implementation is same. So understand the user data, understand the appended data, remove the appended data, and send the user data only. So this type, in this kind, right? So they are trying to address, and they will not remove that 32-bit attacked data who is sent by a hacker. They will try to analyze that also, 32-bit, who sent this data, from where this 32 beta is coming in, what is a email address, what is a MAC address, so everything, so IMEI number, everything they will try to track. And and side by side they will try to send an alert message to cyber, hey, this is an attack that is coming in, as a first warning, second warning. If they keep sending every time, there's high chances the data can be forwarded to the intelligences. Okay.
Okay, sir. Okay. Thank you very much, sir.
Thank you.
Any other questions? So if there are no other questions, we may wind up. Sumati ma'am.
Yes, ma'am. Yes, Nagaraju sir. So it was really a wonderful session. Though we used to teach them all the theory aspect of IoT. I hope it really eye-opener session. Like you explained, like apart from the functional aspect, you also covered most of the security aspect. No, that's very evolving, I guess, right? Because we face a lot of, as you mentioned, the cyber threats also, and also the hardware threats, and we also face a lot of software threats. And I hope this session is really useful session, even not only for the students and also for us. So yeah, so thank you for the session, sir. Yeah, I think this opened a lot of research avenues and also project ideas for students, I guess. So they might be working more on this. Thank you for this session, sir.
Very much.
Thank you, sir. Thank you for joining us. We expect more lectures from you in this way, practical lectures from you. We're happy to have you here. Thank you so much.
Thank you. I'm glad to be part of, sharing some session, and wish you all the best for everyone. Thank you.
Thank you.
Yes.
Thank you
Thank
all the participants for joining. Thank you for your patient listening too. Thank you, everyone. Thank you, sir. Thank you, ma'am.